Imagine, for a moment, that you are floating in darkness. There is no up or down, no floor beneath your feet, no ceiling above your head. There is only a soft, endless night, and a quiet sense of drifting. Far away, you notice a warm glow. At first, it is only a faint suggestion, a slight brightening of the dark. Slowly, gently, it grows. It becomes a star, and then, as you drift closer in your imagination, it becomes our star, the Sunday. We are used to thinking of the solar system as a simple picture in a textbook. A bright sun in the center, neat circles around it, Mercury, Venus, Earth, Mars, then wider circles, Jupiter, Saturn, Uranus, Neptune, and perhaps a few smaller objects dotted around the edges. On the page, everything feels tight and compact. The planets are all squeezed together so they fit on a single sheet, a single screen, a single human glance. In reality, the solar system is almost completely empty. The space between worlds is so large that our usual sense of distance, built for rooms and houses and roads, simply does not apply. We know the words, millions of kilometers, billions of kilometers, but our minds treat those words like fog. They drift past us, impossible to grasp. Tonight, we are going to do something different. We are going to gently shrink the solar system down to a size that we can imagine. We will not rush. We will not hurry through the planets. We will take our time, walking slowly, step by step, from the sun, past the inner planets, out to the giants, and then far beyond them, to the dim and distant borders. Along the way, we will not only talk about what these places are, but also how far apart they truly are. As you listen, you can imagine yourself strolling through a very long, very quiet park at night. Perhaps there is a cool breeze. Perhaps there is a faint crunch of gravel under your feet. Above you, instead of streetlights, hang worlds, tiny glowing beads marking the orbits of planets. The path is long, but you do not have to move. You can simply drift with the story. To begin, we need a scale. The real distance from the Earth to the Sun is about 150 million kilometers. We call this distance 1 astronomical unit, or 1 AU. If we try to imagine that number directly, it does not feel real. So, we will choose a simple, gentle scale model. Imagine that 1 astronomical unit, the distance from the Earth to the Sun, is only 1 meter, a single step. In this model, if you stand at the Sun, you would only need to take 1 calm, ordinary step to reach the orbit of the Earth. Mercury, Venus, Earth, and Mars will all fit within just a few relaxed paces. The outer planets will be farther away, many steps down the path, and beyond them, the Kuiper Belt and the Oort Cloud will stretch out to distances that require not just steps, but long, patient journeys. We can also imagine the size of the Sun and the planets. Let us say that in our mind's model, the Sun is a bright ball, a few centimeters across, like a small lamp, or perhaps an orange in your hands. The planets will be tiny compared to it. Earth will be like a small bead or a grain of pepper. On the page, planets often look like big, colorful circles. On our scale, they will be almost too small to see. That is the first hint that our intuition is not used to these enormous differences in size. So let us stand, in imagination, next to our little Sunday. Close your eyes, if you want, and picture a quiet, dark space. In the center is a warm, softly glowing sphere, our star, scaled down to something you could hold. Everything in the solar system orbits this one object. The planets, the asteroids, the comets, even the far-flung icy bodies on the edge, all of them are bound to this star by gravity. The real Sun is a huge ball of hot plasma, mostly hydrogen and helium. At its core, hydrogen atoms are crushed together by immense pressure and temperature. They fuse into helium, releasing energy. That energy slowly battles its way outward, is emitted as light and eventually reaches us as sunshine. We feel it on our skin as warmth. We see it reflected off clouds, water, and leaves. We live, every day, in the gentle glow of a thermonuclear furnace that is carefully balanced against its own gravity. In our model, this dramatic physical process is reduced to a small sphere of light at your feet, but the meaning remains. Almost all of the mass of the solar system is in the Sunday. More than 99% of everything that has weight, everything that has mass, is in that one central star. Everything else, the planets, the moons, the asteroids, the comets, is left with the remaining fraction of a percent. We live in the leftovers, circling the main event. Now, imagine stepping back a little, so you can see not just the sun, but the hint of orbits around it. Invisible circular paths, like rings drawn in the air. Closest to the sun, hugging the warmth, is a tight inner orbit. This path belongs to Mercury. Mercury is the closest planet to the Sunday. In reality, it is a small, rocky world, heavily cratered, airless, and exposed to intense sunlight. Its surface is blasted by radiation and temperature extremes. On our scale, Mercury is tiny. If the Sun is a ball a few centimeters across, Mercury is a dot, a speck, like a grain of sand. It orbits at about 1/3 of the Earth's distance from the Sunday. So, in our model, if Earth is 1 meter away, Mercury is only about 1/3 of a meter from the Sunday. You could reach out with your arm and cross most of its orbit. Imagine walking from the Sun to Mercury. It is only a short step. You take one small movement forward, and now you are standing near the inner orbit. The Sun behind you is still large and bright. If this were real, you would feel its light unbearably intense. But here, in the quiet of your mind, it is gentle. You can take as long as you like to explore this tiny ring. Mercury moves quickly in its orbit. Because it is so close to the Sun, the gravitational pull is stronger there. Planets nearer to the Sun move faster. Mercury completes an orbit in only about 88 days. It is like a small, quick messenger, circling the Sun again and again, endlessly repeating its path. In our scaled-down space, you might picture a little bead racing along a circular track near the central light while you stand and watch. Now you turn your attention outward, toward the next orbit. Between Mercury and the next planet, there is space, not a few centimeters, not a narrow gap on a chart, but room for another calm step. That next orbit belongs to Venus. Venus is often called Earth's sister planet. It is similar in size and mass, a rocky world, not too different in bulk from our own, but its surface is hidden beneath a thick, opaque atmosphere rich in carbon dioxide, with clouds of sulfuric acid. The greenhouse effect on Venus is extreme. The surface temperature is hot enough to melt lead. If you could stand there, you would be crushed by the pressure and burned by the heat. It is a world that looks bright and serene from above, but is harsh and unforgiving below. On our 1 meter per AU scale, Venus orbits at about 3/4 of a meter from the Sunday. So, from Mercury's path at about 1/3 of a meter, you take another gentle step outward. You pause, standing now near where Venus would circle. If you look back, the Sun seems a little smaller than it did at Mercury's orbit, but still dominates your view. The distance between Mercury and Venus is not just a thin line, it is enough room for another full stride, another region of mostly emptiness. In many science fiction movies and illustrations, the inner solar system looks crowded. Ships dart between rocky asteroids and closely packed planets. But as you walk through this imagined space, you notice how much nothing lies between orbits. Mercury's orbit is a ring. Venus's orbit is another ring. Between them is dark space, nearly empty, with tiny traces of dust and scattered particles, but almost nothing that would block your path. From Venus, we move outward again. In your mind, you take a slow breath and another step. You are now 1 full meter from the Sun at the orbit of the Earth. This is home. The Earth is a small, rocky planet covered mostly in oceans, wrapped in a thin atmosphere of nitrogen, oxygen, and traces of other gases. From space, it shines as a blue and white sphere. Blue from water, white from clouds, brown and green from lands and forests. On the scale we are using, the Earth is tiny compared to the Sunday. If the Sun is a ball a few centimeters across, Earth is less than a millimeter, a tiny bead, barely visible at arm's length. Yet, this tiny bead is where everything we know has happened. Every person who has ever lived, every story ever told, every city ever built, every forest, every ocean, every memory, all on this small dot at 1 meter from the Sunday. The very idea is both humbling and strangely comforting. The universe is enormous, but our home, though tiny, is immensely rich in detail. Orbiting the Earth is the Moon. The Moon is our largest and closest neighbor in space. People often imagine the Earth and Moon as 2 balls very close together, almost touching. In drawings, the Moon is often shown right next to the Earth, just a small distance away. In reality, the Moon is much farther than our intuition suggests. On the scale where the Earth is a tiny bead, the Moon is about a quarter of that size, a smaller speck, but it is not pressed up against the Earth. The distance between Earth and Moon is about 30 times the Earth's diameter. If Earth were a marble, the Moon would be another much smaller marble, several marbles away. Not touching, not side by side, but separated by a surprisingly large stretch of space. Imagine holding the Earth in one hand, the Moon in the other. You separate your hands by some distance until the proportion feels exaggerated. In truth, this exaggerated spacing is closer to reality than the tight, compact images we usually see. The space between Earth and Moon is wide enough to fit all the other planets of the solar system side by side, if you could shrink them appropriately. Space is always bigger than it looks. From the orbit of Earth, we take another step outward. Our path leads us to Mars, the red planet. Mars orbits the Sun at about 1.5 astronomical units. In our model, that means it lies about 1.5 meters from the Sun, half a meter beyond Earth's path. You move another slow, relaxed step down the dark, quiet path. Mars is smaller than Earth, colder, and drier. Its thin atmosphere cannot hold much heat. Its surface is a desert of dust, rocks, and ancient scars carved by wind and perhaps long-vanished water. From orbit, we see valleys, dried river channels, ice caps at the poles, and huge volcanoes and canyons. It is a world that feels both familiar and alien, like a cold, empty cousin of Earth. On our scale, Mars is a little smaller than Earth, another tiny bead in orbit. The distance from Earth to Mars changes over time, because both planets move around the Sun at different speeds. Sometimes they are on the same side, closer to each other. Sometimes they are on opposite sides, far apart. Even at their closest, though, the gap is huge in human terms. If you tried to cross that gap at walking speed, even in our reduced model, it would take a very long time. Now, pause where you are, standing between the orbits of Earth and Mars in your mind. Look back toward the Sunday. You can imagine the inner solar system as a cluster of paths. Mercury's orbit at about 1/3 of a meter, Venus at 3/4 of a meter, Earth at 1 meter, Mars at 1.5 meters. From the Sun to Mars, everything is contained within a distance that you can cover with just a handful of steps. This region is sometimes called the inner solar system, the realm of the rocky planets. It is the busiest place in terms of solid surfaces, where sunlight is strong enough to keep water liquid in some places and where rocks and metals are more common than ice. But even here, even in this so-called crowded region, most of what lies between the planets is emptiness. The worlds are like tiny floating islands, drifting in a wide, dark ocean. Beyond Mars, we reach a transition region, the Asteroid Belt. In movies and games, the Asteroid Belt is often shown as a place where rocks are packed closely together, where a spaceship must constantly dodge tumbling boulders. In reality, the belt is nearly as empty as everywhere else. The Asteroid Belt lies between roughly 2 and 3.5 astronomical units from the Sunday. On our scale, that means it stretches from about 2 meters to 3.5 meters. If you imagine yourself walking from Mars's orbit at 1.5 meters out to 2 meters, then 3 meters, then 3.5, that whole region is where the belt resides. But you will not be bumping into rocks. You could walk for a very long time without seeing anything close by. There are indeed many asteroids there, millions of rocky bodies of all sizes, from tiny pebbles up to dwarf planet-sized objects like Ceres. But they are spread out over such a huge volume of space that, on average, any given asteroid is very far from its nearest neighbor. If each asteroid were the size of a house, the next house might be hundreds or thousands of kilometers away, far too distant to see without a telescope, or even to notice at all if you were simply drifting through. So, as you walk through the imagined asteroid belt, you can picture, here and there, a dim point of light glinting off a distant rock. But they are rare, distant, and isolated. In between is the same almost perfect emptiness. Gravity holds everything in orbit, but it does not fill the gaps with matter. Ceres, the largest object in the belt, is still tiny compared to planets. It is a dwarf planet, an icy, rocky body that orbits quietly among countless smaller objects. On our scale, it would be a microscopic speck compared to the Sunday. From the Sun's point of view, all these asteroids are like dust, important dust, interesting dust, but dust nonetheless. We keep walking outward. With each step, the sun behind us appears smaller in our mind's eye. It is still the brightest object by far, but it no longer fills your field of view the way it did near Mercury or Venus. The distances now begin to stretch more dramatically. Eventually, we reach a distance of about 5 astronomical units from the Sunday. On our scale, this is 5 meters. If you turn around and look back, the inner solar system now fits into a small patch of space near the Sunday. The orbits of Mercury, Venus, Earth, and Mars are all relatively close together inside that 5-meter span. Beyond them, at 5 meters, is Jupiter. Jupiter is the largest planet in the solar system. It is a gas giant, made mostly of hydrogen and helium, with no solid surface like Earth's. It is more than 10 times wider than Earth, and more than 300 times as massive. If you looked at it in real life, you would see bands of clouds, swirling storms, and the famous Great Red Spot, a gigantic storm system larger than Earth itself. On our scale, if the Sun is a ball a few centimeters across, Jupiter is still much smaller than the Sun, but far larger than Earth. Earth would be a tiny bead. Jupiter might be like a small marble. Yet this marble orbits a full 5 meters from the Sunday. Between Mars and Jupiter, from about 1.5 to 5 meters on our scale, there is mainly emptiness, with the thin sprinkle of the asteroid belt in between. Jupiter's presence shapes the entire solar system. Its gravity is strong. It influences the orbits of asteroids and comets. It may have helped protect the inner planets by flinging away some incoming objects and redirecting others. It also holds on to a large family of moons, dozens of them. 4 of these moons are big enough to be considered worlds in their own right. Io, with its volcanic activity. Europa, with its smooth, icy surface and possible ocean beneath. Ganymede, larger than the planet Mercury. Callisto, ancient and heavily cratered. On our scale, These moons are tiny dots orbiting the marble that is Jupiter, which itself circles the small Sunday, layer upon layer of orbits, all dancing in the quiet dark. If you imagine yourself at Jupiter's distance in our model, you might picture standing in a very large open field at night, with a small light 5 meters away at the center. Near that light, almost hugging it, are the inner planets, so close together that you might cover their orbits with a single step. You are far beyond them now. They have become a tight cluster near the Sunday. You are now in the realm of the giants. From Jupiter, we travel outward again. The next major planet is Saturn. Saturn orbits the Sun at about 9.5 astronomical units. On our scale, that is 9.5 meters. So, from Jupiter's 5-meter distance, you will walk approximately 4.5 more meters. Try to picture that distance. Between Jupiter and Saturn, in that 4.5-meter stretch, there are no more major planets, only tiny, scattered objects, dust, and the occasional small world. By the time you reach Saturn's orbit, the Sun behind you is smaller still. It is now a distant light, though still the main source of illumination in your imagined space. Saturn itself, in reality, is another gas giant, slightly smaller and less massive than Jupiter, but still enormous compared to Earth. It is famous for its rings, which are wide but incredibly thin. The ice and rock particles that form those rings orbit in a flat, graceful disk. On our scale, Saturn might be slightly smaller than Jupiter. If Jupiter is a marble, Saturn is another marble, perhaps a bit smaller. Its rings would be a thin, delicate halo around it, almost too small to see from far away, yet wide compared to the planet itself. You could imagine reaching out and gently spinning this marble with its fragile ring system, watching it glimmer in the starlight. We pause here for a moment. Look inward again. From Saturn's orbit, at nearly 10 meters, the entire inner solar system is a small, bright region around the Sunday. Jupiter's orbit, at 5 meters, lies halfway between you and the Sunday. The inner rocky planets are all inside that, tightly packed near the middle. Earth, which felt so central when we stood at its orbit, is now just one tiny ring, lost in a distant cluster. Now we continue outward. Beyond Saturn, the distances grow even more. The next planet is Uranus. Uranus orbits at about 19 astronomical units from the Sunday. On our scale, that is 19 meters. From Saturn, at 9.5 meters, you must walk almost another 10 meters. Think of how many steps that might be. The gap between Saturn and Uranus, on this scale, is greater than the entire distance from the Sun to Saturn. Yet in between, there are no large planets, no big objects demanding attention, just space. Uranus is an ice giant, a planet composed largely of water, ammonia, and methane, in forms that are not quite liquid, not quite gas, but something in between, under high pressure. It is pale blue-green in color. One of its most unusual features is its tilt. Uranus is tipped so far over that it essentially rolls around the Sun on its side. Its seasons are strange and extreme, with one pole facing the Sun for long periods, then drifting into darkness as the other pole takes its turn. On our scale, Uranus is another small marble, fainter and colder. It circles the Sun at 19 meters. If you stand at its orbit and look back, the Sun seems smaller, perhaps like a tiny lamp glowing in the distance. The inner planets, the Asteroid Belt, the orbits of Jupiter and Saturn, all of them are now crowded into a small region around that distant light. From Uranus, we go farther still. The next giant is Neptune, also an ice giant, known for its deep blue color and strong winds. Neptune orbits the Sun at about 30 astronomical units. On our 1 meter per AU scale, that means it lies 30 meters from the Sunday. From Uranus at 19 meters, you must walk another 11 meters. These distances are becoming long. You might imagine walking across a room, then another, then a hallway, just to move from one giant planet's orbit to the next. At Neptune's orbit, the Sun is a distant beacon. It is still the primary light source, still the center of everything, but it no longer dominates the sky. Neptune itself is far from the warmth and energy of the inner solar system. Its atmosphere is cold and windy. It has its own family of moons, including Triton, a large moon that may be a captured Kuiper Belt object. Looking back from Neptune, you see the solar system in a new way. The inner planets are a tiny, bright knot near the Sunday. Jupiter and Saturn are faint circles, a fraction of the distance between you and the center. Uranus is somewhat closer, but still far behind. Most of what lies between you and the Sun, and between you and the darkness beyond, is empty. But we are not at the edge yet. Beyond Neptune lies another region, the Kuiper Belt. The Kuiper Belt is a donut-shaped zone of icy bodies, extending from about 30 astronomical units to perhaps 50 astronomical units or more from the Sunday. On our scale, that is from 30 to 50 meters. Neptune orbits near the inner edge of this region. Here, in the Kuiper Belt, live many small, icy worlds. Some are large enough to be considered dwarf planets: Pluto, Haumea, Makemake, and others. These objects are remnants from the early days of the solar system, bits of ice and rock that never formed into full-sized planets. They circle quietly in the far cold, warmed only faintly by the distant Sunday. Imagine walking from Neptune's orbit at 30 meters out to 40 meters, then 50. This entire span is the Kuiper Belt, and like the Asteroid Belt, it is sparsely populated. On a human scale, if you chose one Kuiper Belt object to stand on, the next one of similar size might be millions of kilometers away. They are not crowded together. They drift alone in a huge, dark volume. Pluto, once called the ninth planet, is one of these Kuiper Belt objects. It follows an elongated orbit that sometimes brings it closer to the Sun than Neptune, and sometimes carries it farther out. On our scale, Pluto's average distance of about 39 astronomical units places it at 39 meters from the Sunday. Pluto is tiny smaller than our moon. If Earth is a small bead in our model, Pluto is an even smaller grain. Standing at Pluto's distance in your imagination, you feel the vastness of space. From here, if you look back, the Sun is a distant, bright star at the center of a vast spherical space. All the orbits of the planets, all the familiar names, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, are inside the region between you and that distant Sunday. They feel crowded together now. The entire known solar system, all the places we talk about most often, lie within just 40 meters of that central star in our model. But even the Kuiper Belt is not the true edge. Far beyond it, scientists believe there is another enormous region, the Oort Cloud. The Oort Cloud is a hypothetical, spherical shell of icy bodies that surrounds the solar system. Its inner edge may begin at a few thousand astronomical units from the Sunday. Its outer edge may extend tens of thousands of astronomical units into space. If we kept using our scale of 1 meter per astronomical unit, the inner edge of the Oort Cloud would be thousands of meters away from the Sunday. The outer edge could be tens of thousands of meters away. This is far larger than any room, any field, any park. We would have to imagine walking for hours and hours in our mental model, leaving the orbits of Neptune and Pluto far behind, until finally the Sun was only a bright dot in the darkness, one star among many. In this distant place, the Sun's gravity is weak, but still present. Icy bodies drift in slow, long orbits that might take millions of years to complete. Sometimes, the gravity of a passing star or the subtle pull of the galaxy itself, nudges one of these objects inward. It begins a long journey toward the inner solar system, falling toward the Sunday. When it gets close enough, it may become a comet, growing a tail as sunlight warms its ice. From the edge of the Oort Cloud, if you could somehow hover there and look back, the entire solar system that we know from the Sun, out to the Kuiper Belt, would fit into a tiny region of space. The orbits of the planets would be almost indistinguishable, all crammed near the center. The Sun itself would look like an ordinary bright star. Only careful observation would reveal that the light from that star is slightly stronger nearby, slightly more dominant than the others. To truly feel the scale of the solar system, it can be helpful to think not only in terms of distance, but also in terms of time. How long does it take to travel across these spaces? We can think of different speeds. At a gentle walking pace, perhaps 5 kilometers per hour, you could walk across a city in a few hours, or across a small country over many days. At that speed, if the Earth-Moon distance was scaled down to a more manageable size, you could cover it in a reasonable time. But in reality, the actual Earth-Moon distance is about 384,000 kilometers. Even in a fast car, you would need many days to cover such a distance, and there is no road in space to follow. Spacecraft move much faster than cars or airplanes. The rockets that send missions to the Moon, to Mars, and beyond accelerate them to speeds of thousands or tens of thousands of kilometers per hour. Even so, it takes days to reach the Moon, months to reach Mars, and years to reach the outer planets. Some of our fastest spacecraft, like the Voyagers and New Horizons, have reached speeds of many kilometers per second relative to the Sunday. At those speeds, they have traveled for decades and are only now moving beyond the orbits of the outer planets. They are still within the region dominated by the Sun's gravity. They have not yet reached the inner edge of the Oort Cloud, and they will not for a very long time. If you think of the solar system as a kind of cosmic ocean, each planet is like an island. Our spacecraft are like small boats that have ventured from the shores of one island to another. So far, we have mostly explored the islands close to home. We have sent orbiters and landers to Mars, flyby missions to the outer giants, and probes into the atmospheres of some worlds. But the ocean between the islands is wide. We have dipped our toes into it, but we have not crossed the whole expanse. Time and distance are deeply linked in space. To go a long way, you must travel for a long time, unless you can move at an enormous speed. Even light, which is the fastest thing in the universe, takes time. Light from the Sun takes about 8 minutes to reach Earth. It takes over 4 hours to reach Neptune. It takes many hours to reach the outer edge of the Kuiper Belt. To cross the distance to the near side of the Oort Cloud, light would need many months. To reach the far side, perhaps a year or more. When we look up at the night sky and see stars, we are looking at light that has traveled for years to reach us. Some of it has been crossing space for centuries, millennia, or longer. We are seeing those stars not as they are now, but as they were when that light began its journey. Our own Sun, from far away, would also appear as a star, its light traveling outward across vast distances, eventually reaching the eyes of hypothetical observers on distant worlds. Now take a step back, in your imagination, beyond the outer reaches of the solar system. From this vantage point, you can see the solar system as a tiny bubble of influence around the Sunday. The Sun sends out not only light, but also a stream of charged particles called the solar wind. This wind carves out a cavity in the thin gas between the stars, creating a region called the heliosphere. At some distance from the Sun, the pressure of the solar wind balances with the pressure of the interstellar medium. That boundary is one of the edges of the Sun's domain. Beyond that, the galaxy stretches in all directions. The Milky Way is a vast collection of stars, gas, dust, and dark matter, arranged in a flattened, rotating disk with spiral arms. There are hundreds of billions of stars in our galaxy. Many of those stars likely have planets of their own. Our solar system is just one example among many, tucked away in one spiral arm, far from the center. If we were to shrink the entire solar system down even further, compressing the orbit of the outermost comets into something as small as a grain of sand, then the distance to the nearest star would still be enormous. If the solar system were a grain of sand, the nearest grain representing the next star system might be meters or tens of meters away. The galaxy would be like a beach strewn with grains of sand, each one a star and its planets, spread out over a huge area. The true scale of our solar system is not only large in itself, but also small compared to the galaxy, which is small compared to the distances between galaxies, and so on. We live in a hierarchy of vastness. Each time we zoom out, what once seemed huge becomes tiny. Yet even as we talk about these enormous distances, we remain on our little world, going about our daily lives. We move from room to room, from building to building, from city to city. Our everyday distances are small and familiar. Our roads fit on maps. Our world fits on a globe. It is easy to feel that what we see is all there is. But above us, beyond the atmosphere, beyond the moon, beyond Mars and Jupiter and Saturn, there is this quiet, spacious architecture of orbits. Invisible lanes traced in 3 dimensions, each one the path of a planet or a smaller body, all kept in motion by gravity. The solar system is both immense and simple, a star in the middle, and things that go around it. Now, as you rest, you can imagine drifting outward, slowly from Earth. First through the familiar environment of satellites and space stations, then through the emptiness beyond. The moon passes by, a pale disk growing smaller as you move away. Soon, Earth and moon are a single point, then a faint spark against the black. You keep drifting. The orbit of Mars slides beneath you, then the asteroid belt. You may picture a few scattered rocks bathed in weak sunlight. Then Jupiter appears, large and striped, accompanied by its moons. You pass it at a great distance, watching it slowly shrink behind you. Saturn follows, with its elegant rings. Perhaps you pause in your imagination to admire them, and then continue. The giant forms of Uranus and Neptune drift past, pale and distant. Each time you pass another orbit, the sun grows smaller, the inner worlds cluster closer together, and the darkness around you deepens. Eventually, you cross the realm of Pluto and the Kuiper Belt. Now, the sun is a bright star behind you, its light still the strongest, but no longer overwhelming. You are in the far outer reaches of the solar system. From here, the sun and its planets are a small family of lights close together, a tiny system immersed in the wider galaxy. If you continue farther still, into the region of the Oort Cloud and beyond, the solar system shrinks to a single point in your awareness. Other stars appear, scattered across the sky. Some are closer, some are farther. Each one may have its own planets, its own version of Mercury and Venus, its own Earth-like world perhaps, its own distant ice giants and comets. You float in this imagined space, calm and weightless. You know that, in reality, you are lying still or sitting somewhere safe, listening. But your thoughts can roam freely, riding on the gentle structure of these distances. The numbers millions of kilometers, billions of kilometers, astronomical units, light years, become less important than the feeling. The feeling that the universe is wide, quiet, and filled with subtle beauty. And somewhere in that immense structure, on a small, blue planet, 1 meter from its star in our imagined model, you exist. You breathe. You think. You can look up at the sky, or close your eyes and picture it. You are small compared to the solar system, and smaller still compared to the galaxy, And yet you are made of the same atoms, the same physical laws, the same starlight. The iron in your blood was forged in ancient stars that lived and died long before the sun was born. The oxygen you breathe was produced by life on Earth. But the elements that make up your body were once part of clouds of gas and dust in interstellar space. When the sun and planets formed, they gathered that material into new shapes. Some of it became worlds. Some of it became oceans and mountains. Some of it eventually became you. So when you think about the true scale of our solar system, you are not only thinking about something outside yourself, you are thinking about the larger structure of which you are already a part. You are not separate from it. You are one small expression of it, an arrangement of atoms that has become aware of the space it inhabits. Now, let all these distances gently fade into the background. The sun, the planets, the belts of asteroids and icy bodies, the distant Oort Cloud, the galaxy beyond all of it is still there in your mind. A quiet, stable structure. But you do not need to hold on to the details. You can let the names and numbers drift away, like leaves on a slow river. What remains is a sense of calm vastness, a sense that space is deep and wide, but also peaceful and patient. Orbits continue, whether you think about them or not. Planets circle their star in silence. Comets trace long, graceful paths over millions of years. Stars rise and set from the point of view of distant worlds. You, for now, can rest. You can imagine yourself lying back in that immense dark, watching the tiny glow of the sun and its planets from far away, or you can imagine yourself curled up on the surface of Earth, safe under its thin atmosphere, as the planet moves gently along its orbit. In either case, there is nothing you need to do, no place you need to go. The solar system will keep turning. The sun will keep shining. Breathe in slowly, breathe out gently. With each breath, you can picture the entire solar system breathing with you in a slow, steady rhythm. The inner planets, closer and warmer. The outer planets, distant and calm. The Kuiper Belt and Oort Cloud, almost motionless on human timescales, yet still moving, still orbiting. You are here, in one small corner of that structure, resting. The distances are immense, but you do not have to cross them. You can simply know that they exist, that the universe is larger than your worries, larger than your thoughts, larger than this moment. And somehow, that largeness can make this moment feel gentle and light. Let the image of the sun recede now, shrinking down until it is only a warm point of light in the distance. Let the planets become invisible, their orbits implied, but unseen. You can allow the darkness to close softly around you, like a comforting blanket of night. The true scale of our solar system, the true scale of space, can now carry you towards sleep, quietly and kindly, one breath at a time.